Hello and welcome to my YouTube channel. I am your Jaleel sir. Today one more lecture on alkanes. In the previous two videos we discussed general methods of preparation of alkanes. That is how alkanes are prepared. Today we will learn about the physical properties of alkanes. That is physical properties. Very informative video, you will find it. Physical properties of alkanes. Physical properties of alkanes. As I have already told you, alkanes, they do not have any functional group. They are least reactive towards reagents. Okay? They are non-polar. That is why they are called paraffins. Paraffins. Least reactive. For example, we have this alkane. This one. C and C. Ethane, for example. No functional group. Okay. They are not attacked by reagents. They are not attacked by reagents. Okay, beta? Under normal conditions. But at high temperature, they can show some reactivity. Okay, beta. Now, first thing we'll learn about is citate. That is, in which state of matter they exist. Whether they exist solid, liquid, or gas. We will learn about it. So first thing, alkanes from carbon 1, that is methane, up to carbon 4, butane, up to butane are gases. Okay. Colorless gases from C5 to C17, that is alkanes which contain 5 carbons up to 17 carbon alkane, they are liquids. Okay. Liquids, and from carbon 18 onwards they are solids at room temperature at 298 Kelvin. So this is the first information which you have to remember is from carbon 1st to carbon 4 they are gases, from carbon 5th to carbon 17 they are liquids at room temperature, and alkanes from carbon 18 onwards are solids at room temperature. First thing. Now second property of alkanes is solubility. What about their solubility? Are they soluble in water? No, they cannot be soluble in water. Why so? Because they are non-polar. So I will write alkanes are non-polar in nature. Alkanes are non-polar in nature. Very important point. So non-polar molecules, they are insoluble in water because water is a polar solvent. They are insoluble in water. Okay, but they are soluble in organic solvents like alcohols, ethers, but they are soluble in organic solvents like alcohols, say ethanol, and ethers. Okay, because non-polar molecules are soluble in non-polar solvents, or simply we call them organic solvents. Is this clear? They are insoluble in water but soluble in organic solvents. Prominent among them are ethers, alcohols. Okay, good. One more thing. Solubility decreases with increase in the number of carbons. That is, if the carbon chain increases, then solubility decreases. Let me write it. Solubility decreases. Solubility decreases with increase in the length of carbon chain. Okay, very important. So when the length of carbon chain increases, molecular mass increases, then solubility decreases. Is this clear? Good. Then we will move on to third physical property of alkanes, that is called boiling point. Boiling point of alkanes. Boiling point. So the third property is boiling point. Boiling point. Okay. Now what is boiling point? The temperature at which liquid phase and the vapor phase of a substance coexist or simply exist in equilibrium. For example, boiling point of water is 100 degrees Celsius. Okay, that means at 100 degree liquid phase of water and its vapor phase exist in equilibrium. At equilibrium they have same vapor pressure, liquid phase and vapor phase. Okay. So what about boiling point of alkanes? First point I will write, alkanes have low boiling point as compared to other organic compounds like alcohols, isn't it? Alkyl halides, aldehydes, ketones. Because in alkanes there is no polar group, polar functional group. So the intermolecular forces in alkanes are generally weaker van der Waals forces. Weak van der Waals forces. That's why they have lower boiling points. Alkanes have low boiling point. Lower boiling points. Due to absence of any functional group, polar functional group. So in alkanes we will not find strong force of attraction like hydrogen bonding, dipole-dipole interaction or dipole-induced dipole interaction. Then what kind of intermolecular forces we find in alkanes? Only weak van der Waals forces. Due to weak van der Waals forces. Which operate in alkanes. For example, if I take methane and if I take methanol, you can see methanol has higher boiling point because of OH group, and you know oxygen is polar. Oxygen is more electronegative than hydrogen. It will become polar, and polar groups form hydrogen bonds. Oxygen forms intermolecular hydrogen bonding. That will increase the boiling point. So, what I want to say is absence of any functional group, polar group in alkanes makes them low boiling hydrocarbons, low boiling organic compounds. Okay, fine. Now, second point, if we increase the number of carbons in alkanes, that will increase the molecular mass. What will happen to boiling point? That will increase, obviously. I will write it. So I will write second point. Boiling point increases with increase in number of carbons. Okay. So with increase in number of carbons, boiling point increases. Why so? Because molecular mass increases. So I will write methane, then ethane, then propane, okay, then butane. Got it? So increasing boiling points. Increasing boiling points. Remember it. So butane will have higher boiling point than propane, and boiling point of propane is higher than ethane. Okay, beta. Now one more thing I will tell you. What about isomers? What are isomers? We have already discussed isomerism in alkanes. Chain isomerism. Same molecular formula, but they differ in the nature of carbon chain. Sometimes citrate chain, sometimes branched chain. You have to remember a rule. of thumb, that is with branching for isomeric alkanes. For isomeric alkanes, that is alkanes which are isomers, boiling point decreases with branching. So I am right. For isomeric alkanes, isomers, alkanes which are isomers, for isomeric alkanes, boiling point decreases with branching. Okay. For example, this is pentane, N-pentane. C5H12. Okay. Its boiling point is higher than isopentane. This is isopentane or 2-methyl-butane. Isopentane. Okay. So one branching here at carbon number 2nd. And boiling point of isopentane is higher than boiling point of neopentane. This is neopentane, beta. Okay. Neopentane. Two branchings. This is neopentane. Neopentane. Now you will ask a question, sir, how? If they have same number of carbons, same number of hydrogens, same molecular mass, now why branching decreases boiling point? I will tell you. With branching, surface area of the compound decreases. You can see this becomes somewhat spherical. It is surface area decreases. When surface area decreases, then number of atoms, number of active sites, number of sites which interact through van der Waals forces decrease. So less surface area means less number of interactions. So when number of interactions decrease, then boiling point decreases. So I will write it with branching, boiling point decreases. See, with branching, boiling point decreases. Due to decrease in surface area. Surface area. And when surface area decreases, van der Waals forces decrease. Okay? That decreases boiling point. I hope the concept is clear. Good. Thank you for watching the video. Subscribe to my channel for more such videos.